All right, in the third part of this video, we're going to take a closer look at how we can use the friction bump model to predict which way friction is. After all, it's a pretty common misconception that friction always opposes the motion of an object. And for the most part, in the examples that we see, it does. However, there are some examples where it doesn't. So let's take a look at those. All right, so let's imagine somebody walking. This is a very interesting example of friction. So in the case of somebody walking, when you take a step, you sort of push your foot backwards a little bit and then lift up. And that shove backwards actually causes the floor to push you forward like that. And without friction, you couldn't operate, you couldn't walk. So again, friction allows you to slide your foot backwards on kind of a microscopic scale, and then that allows the floor to accelerate you forward. And when you land, the floor slows you down. So for a person moving this way to the left, friction on one hand speeds them up and on the other hand slows them down. Let's take a look at the friction block model and see how that can explain that. So this will be the floor, and this will be your shoe. So your foot's on the ground, and you're ready to take a step forward. On a microscopic scale, what happens is your foot slides back like that, and it allows those friction bumps, like here, to interact, putting a force that way on your, let's just take those guys to look at, putting a force that way on your shoe. That force really isn't balanced by any other force, and hence your body and your shoe accelerate forward like that. Now, let's go to the part where you're about to land. I'm going to erase these there, and let's go to where you're going to come in for a landing. So now your foot, you've taken the step and you're going to step back down on the floor, and you need your foot to slow down. So as your foot comes in like this and it slides forward, and bam, those friction bumps begin to interact right there and right there. And so at that point, friction actually pushes backward against you to slow you down. See, friction always opposes the sliding or the slipping of the surfaces. It doesn't necessarily oppose the motion of your body. In the case of you taking your first step forward, in fact, it pushes you forward. Only when you bring your foot down does it push backwards on you. So friction doesn't always act opposite to the motion of the object, but it does always oppose the sliding. Let's take a look at that one more time. So when you push off with your foot, the floor pushes off on you. Then in that case, friction is pushing forward on you to accelerate your foot forward. Then when you land, friction pushes backward on you. Now there's another interesting example of that, and that has to do with a wheel. So let's grab the wheel over here, and let's imagine the road is here, and we're going to drive our car on the road. My wheel to be a bigger size. There we go. So here's your car parked on the pavement, and you are ready to get your car going. So your engine turns the wheel, and by turning the wheel, you cause the friction bumps from your wheel to interact with the friction bump on the road, and that pushes your car forward. It's actually the spinning of the wheel like this that's done by the engine that causes those friction bumps to interact in such a way that friction pushes that way on your car, even as you're trying to go that way. Yet another example of where friction doesn't oppose the motion, it actually causes the motion. Now let's look at a case where friction would be the other way on a wheel, because there are such cases. All right, so let's say instead of having a wheel that's driven, instead let's imagine this is maybe the rear wheel of your car. So the rear wheels are not driven by the engine. All right, if it's the rear wheel of your car, then in fact what your car is doing, your rear wheel is doing, is being dragged along the road like this until right there's a friction bump interaction. And that friction bump pushes backwards on your wheel, and that causes your wheel to spin. And then you go forward again, and it causes it to spin again, like that, like that, like that. And we'll take a look a little bit more in the last section of the video.